Hello there. My name is Michie, the CEO at Proxima, and today I'm delighted to be joined by Mr. Michie. Mr. Michie is a seasoned professional in the space of artificial intelligence, a personal mentor of mine. I met Michael a couple of it was 2021 or 2.
Yeah, 2022.
Yeah, sure. And I think since we met, we've been speaking on phone, talking about artificial intelligence, sharing the love of that particular sector. And finally, we met this particular year. We now go to speak, simply now exchange about some of the things that we do. And I think, first of all, Michael, welcome. It's a pleasure being with you here. And you can first of all start by now talking about like your past now experience, basically.
Yeah. Thank you, Beckham. Nice to be here. Nice to see the company up and running. It's been a nice journey to watch as a bystander. So my journey around artificial intelligence, normally I say it started when I started interacting with video games. So I think that was when I was probably in class 6 or just around there. I was very intrigued by the non-playable characters, the NPCs. And so I felt I need to understand how they do, how do you get them to behave autonomously? How do they, I was just like very curious into that. So my love for video games is what drove me into artificial intelligence. And then that got me obviously interested into technology. And so I then at that point decided maybe not to be a doctor, but let me do something with computers. So then since then I've just focused on that. Then I worked in banking, I worked in fintech, I've worked in legal, but as an IT professional, not as a lawyer. And now currently doing a bit of consulting, as I also set up my own startup that's doing artificial intelligence for data protection, data privacy, and offering AI as a service.
Okay, sure. Yeah. Well, that's a very good background of you. Okay, so like my first now question is, as a 10-year-old Mike, like what was your now character basically in terms of playing, in terms of now playing video games?
I just wanted to, I think I grew up slightly, I don't say very competitive, but there was a lot of competition between me and my brother, whether it was video games, academics, arts, chess, reading, picking complex careers. I wanted to be a neurosurgeon, he wanted to be a paleontologist. He would read about space, I'd read physics or biology. So we drove each other very aggressively. And because we had the same likes, it was easy. When you learn something, you want to show it off. And when someone else learns something, they show it off. So you learn from each other. And the freedom that video games allowed you to fail and try again, I think that helped me at a very early age to accept that failure is normal and you can have another go at it.
Oh, nice, fantastic. Okay, so like when you talk about now NPCs, okay, like for myself, I think I was the person focusing more on my own now character in the video game, not them, because like I would say, okay, like let me simply kill this person and then I can go. Nobody will come and now pick me from somewhere.
I was just curious, why does that NPC have to appear there? Why are some NPCs friends, others were foes? Why they played differently? And as I played those games and as time went on, you could notice the progression of artificial intelligence. I remember very early on, I think still when I was in high school and in campus, a lot of Google papers would come out about, they have this AI, it's been taught how to play chess, they have this other AI that has learned to,
stuff. The one that beat Gary Kasparov in, I think, 1997.
But that was more brute force, but now we got to the point where
it's much more intelligent.
It's more intelligent because now there was unsupervised learning.
Neural networks and all.
Exactly.
Yeah, for myself, I think I got started in about, like I was in tech from a very young now age. My first site was built now using Microsoft Word, which was just me trying to make some money online, like now simply trying to do some things. But I got introduced to the world of tech at a very, very young age when my dad simply bought a computer. I think that's the first step for like so many people when you see now computer first,
Yeah.
and then you start playing video games. My best game was, I think it was now House of the Dead. I don't know
Oh
whether
yeah,
you
you
played
played
it.
it. I played it.
Yeah, there was this big guy like whom you could never beat no
Yeah.
matter what you did. Yeah, so like I think I got interested in tech. Like I built a site in my first year, second year, third year. But now when you talk about artificial intelligence, like I wanted to be a stock broker myself.
Yeah.
I basically wanted to buy stocks to become the next Warren Buffett.
Yeah.
And I think Warren Buffett was my now mentor. Like was my now mentor.
Yeah.
So like when I wanted to buy stocks, I said, okay, like let me try see like how I can trade stocks with the machine basically.
Yeah.
So I went online, bought a course. Then as I'm doing my course, I saw this particular course, Artificial Intelligence A to Z.
Yeah.
And I said, okay, like let me see what the guy will now offer. And then I saw, okay, like, wow, this guy says that I can build a self-driving car. Which was now just a marketing, like a marketing now gimmick.
Yeah.
But I picked it,
Yeah.
and then I focused on convolutional neural networks for some time, which was simply trying to make sure that machines can see. And I can recall my dad coming every single day, now with a single question, have you perfected? And I'm like, no, I've done this. I'm supposed to do natural language processing still. I'm supposed to do reinforcement learning, and I don't have a background in school in tech. It was purely self-taught. Okay, like now let me teach myself this particular course, and then it happened. Yeah, so like I think that's my own personal journey in tech, and so many people don't know like not so much about artificial intelligence. So like from your own perspective, what's the simplest description that you can now give to like someone like who is now coming to now this particular field?
Oh, I usually say it's an attempt to simulate human intelligence.
Yeah.
I think that's the simplest way,
Yeah.
and I think it's usually important to say it's an attempt at simulation.
Yeah.
Yeah.
Okay, so when you say it's an attempt at simulation, basically, okay, like first of all, we must understand intelligence on its own.
Yes.
Because like there's okay, some people say that there's a that there's some finite intelligence in the world, and at some point we might master like the full scope of intelligence. Do you think that's true?
Not really. So today morning, I was listening to a podcast, but not too keenly.
Okay.
And the same topic actually came up, and it was on the complexities of human thought and consciousness, which then touches on intelligence. And so, for example, an algorithm or a computer software is limited to what it can do.
Yeah, sure.
Traditional softwares had a certain limit, which means if it's a software for video games, it's not going to be a word processor for you.
Yeah, sure. Yeah.
So the argument for a certain philosopher, whose book and work has been referenced but I've forgotten, they were speaking around how the human mind itself is a lot more complex. Yes, we have some of those things which are programmed into us, but we have this quantum side of our brain, of our minds rather, which allows us to sort of have a sense of infinite possibilities within our mind. And that's the thing that we are yet to capture. That's the thing that builds our consciousness, and that also then builds intelligence for us as biological beings, that then needs to be transferred into machines.
Okay, sure.
So when I had that, because I wasn't paying much attention, but I was like, oh, this is something to revisit when I can sit down quietly in a room. But basically what that helped is I felt like it grounded my reasoning around the fact that as much as I am an AI practitioner, the word intelligence in it feels more of a marketing thing than it is. Yes, machine learning is there. But intelligence, I don't think we're yet there. Okay,
sure. So like I think GPT-4 was somehow measured, and the now IQ of it was like I think 120 basically. And so many people do have like something like 100. Like 120 like is a very high limit for so many people. So like do you think it's like something that will now challenge now human intelligence on like now on its own?
No, it's far away from challenging human intelligence. I I think I like it's entertaining.
Yeah.
I'd say it's entertaining, not that I like it.
Okay.
It's entertaining to see the news and how they want AI to be sentient. They want us to go from AI to AGI to to super intelligence so quickly. But when you look at it, our intelligence in itself, you didn't need to be shown maybe 2 million pictures of cats for you to be able to accurately say that this is a cat, at least
like 100%,
100%, yeah, or 90% accuracy, yeah,
without using so much energy.
You consumed so little knowledge or so little information to expand your knowledge. But for the AIs, they still need a lot of information, and it also lacks the agency and autonomy. You have that ability to independently think, independently act. You wake up in the morning, you start your day, you go about it. ChatGPT, other than that, other than last week when we had that it was prompting people before it prompted them and was asking them questions, and OpenAI said it was a bug, it doesn't have that ability.
Okay, so like there's the talk about artificial general now intelligence, but before we now talk about that, there's a certain professor basically now, like they came up with this particular statement. If you can give artificial intelligence consciousness, it means that you can like now give a cat consciousness too, because it's so complex. Like it's not simply like about putting in data and simply now making sure that this particular machine will be smart.
Yeah, it's true. It's an interesting philosophical space to play in, because once you start talking about consciousness, and if you can put consciousness in a machine, then definitely you should put it on a table, a chair, a rock. Then that would mean consciousness. Then you start asking yourself, has consciousness existed within all living organisms? And then if you can add consciousness to replicate it into something, does that mean it was already conscious and then you brought in an external consciousness to it? So it becomes more, it's an interesting philosophical space. I remember I think this was 2018? 2018 or 2019. For the whole year, I didn't code. Just because I was really intrigued between the philosophy of the philosophy itself, and for me it was philosophers always ask questions, and they try to get the answers. And AI was becoming that thing when ChatGPT, when we had the initial efforts around OpenAI and the GPT-2, and I remember Dungeon AI and a few other chatbots that were out there, and they were trying to answer questions, and I was like, okay, philosophy is asking, AI is answering. I've done software, I've done machine learning, so I need to also understand philosophy, because I felt those two would go together if we need to move towards AGI, SI, and also to actually accept what limitations exist. Okay, so like from your findings, like what were you unable to see from a philosophical point of view? From a philosophical point of view, we are miles away. Miles away. Which aspect, basically? Towards AGI or SI. And even if we do get there, we still get to a point where we are simulating human intelligence. And from even what I was listening to today, the possibility of that infinite nature of the human mind means there is a limitation to super intelligence. And then there's also the concept of consciousness and autonomy. And I remember there was a paper I was reading where some scientists in the US were trying to figure out, or trying to prove that our brains have infinite capacity. So what we have is that all humans see, or all humans, whatever information that is fed into your brain is permanently stored there. What we have is a retrieval issue. We remember things, we forget things. So we're not able to retrieve the data fast enough, and sometimes we don't know where it's stored. Machines do that better. But we have infinite systems. So their theory, which they're trying to prove, is that our brains have infinite capacity. We're yet to build a special storage unit that would have infinite capacity. So human intelligence, I think will remain more powerful. And sometimes you can see it even in when you look at philosophy and then you start looking at literature and our cultures and everything. There's always that moment of humans have built something far much greater than them. And then somehow humans are able to conquer it. If you look at like comic books, Marvel comic books, you have Ultron, super intelligent, but defeated again by the humans. They're expecting Ultron to be more powerful. You look at DC comic books, Batman has no powers, but has the intelligence.
He can even beat Superman.
And he beats Superman, he beats the whole Justice League. So I think somehow
there's that aspect of being human basically that now gives up some power.
There is something within all that culture and literature and within philosophy that always makes me think all these things aren't by chance, that it could be that we may at a subconscious level know we'll build things that can do things faster and better than us and more efficient, but we'll never reach our capacity.
Okay. So like I think one thing that I saw, like so many people can see ChatGPT, most of these large language models, but there's a very big background story basically. Because like when I first of all started, it was a simply it was now simply recurrent neural networks. Like which are the very short now memory. Like now of the things that they could now simply now
recall.
With the now proper context. Then someone comes with the paper called attention now is all you need basically. Then that changes the game fully. After that, there's something we call I think it was RLFH. Like I don't know, like
reinforcement learning human feedback.
Which came in and now saved the day. So like I think in a way there's the single now aspect that we are trying to build intelligence via so many machines, via so much data, via so much code. Like which I think like for myself I think at some point machines will be superior to man in terms of like the way things are going basically. Because like if you see the way things are coming up based on the different now architectures, because like Musk full self-driving at some point will become a better driver than me and you. Meaning that whatever will be now left will be like the consciousness itself. So that comes to my point. Do you think that you can separate intelligence and now like a now consciousness, meaning simply now put machines can become much more intelligent than us, but we still get to keep our now our now consciousness?
Yes, in some weird way. From the example you've given even of autonomous cars, I think that's a good example. The car ultimately would be a better driver because it's able to process and make decisions faster. If you had that same capability, I believe you would beat the machine. Because like for the machines, it's receiving so much information and it's not an overload.
It fast.
So it has radar, it's using computer vision.
I think for Tesla, it's purely computer vision. And there was a point whereby Musk said that the one that they were trying,
LiDAR,
like I think it failed because like most of them are now coming back to computer vision. Because like for them they're trying to build like a system that can process it like once it gets that particular vision, it can take it that vision, assess it, then process like what now to do next. But okay, just go on please.
So I think that example of, you see the car, that autonomous car is a better driver than you. But it's only driving. You have other things outside that perimeter that you can do. So it doesn't have that ability to switch between tasks. Maybe in the future, we've seen how you can create small agents that ask other agents to perform
different tasks.
So
agentic systems.
That's one way of looking at the concept of the machines will always be more efficient. I am finding it from a philosophical point of view. I find it very difficult to see them being more intelligent. They'll just be more efficient. Because also if you look at intelligence also as a capability of learning, how much data do you need to teach
minimal.
an AI? A lot. How much data do you need to teach a human?
It's very minimal.
Very minimal. Even, for example, if you're training an animal such as a dog,
you
can train a dog how to sit within a week.
Yeah, true. Yeah.
You'll need to train an AI what a chair is with millions of images of chairs and not chairs. It has to learn what are the characteristics or the features of a chair. How is this chair different from that chair? And they're still chairs.
Yeah.
But for us, the fact that it's a lot easier, I think that's one of the advantages we have. I do hope, though.
Yeah.
And I remember I once had this conversation around when everyone was like, data is the new oil. I was like, but shouldn't we now start asking, because you've made that comparison, would it be unwise for me to start thinking, what is the renewable alternative to data?
Yeah, sure.
And then
that's a very good thought.
Let's start asking, how do we improve algorithms to learn better with less data? Maybe from 2 terabytes now to need only 500 GB and constantly improving and improving beyond there.
Okay, like I think it depends on the architecture being now used. Because I think it's becoming better in terms of like the way things happen. We do have things like transfer learning. We do have things like fine-tuning, which makes it much more simpler. And so like from my side, I think it's simply setting a very, very good base such that when you can build on top of it, we can now simply make it better. Because like for ourselves, like our systems are built on now retrieval, now augmentation. Meaning that you can simply make sure that it's not the now model itself, but you can have data stored in a certain way that you can now power it up with the power of the now large language model itself. And then when we talk about large language models, like the space of artificial intelligence is so broad.
It is.
Because like we do have convolutional neural networks, which is my own personal favorite. Like I spent so much time just learning. There were so many things to build. It was the biggest topic now at some point when they came up with the paper, when now Jensen Huang gave the first GPU. There was some model called Efficient Net, Alexa Net, they simply had that particular characteristic. And then we do have now reinforcement learning, which is a very now critical component basically. And because like if you now see the previous now models, they purely now rely on now reinforcement learning basically for them to pick the next now step of actions. Okay, now we are coming to a very now critical topic. Kenya. Kenya in the space of artificial intelligence. Because like you see, for me and you, we can pick it from the Western world. We can build, we can do whatever we do. But Kenya is a very, very different dynamic. Energy is still a problem. There are no policies. We do have some few people like you, like whom can do some things, but is the market now receptive to you? And like there's so many factors that we should now consider if you are to build like our now own systems basically. And because like I think at some point, the same way we do now import cars, we import phones, we might also be importing artificial intelligence.
We will. we are net consumer of artificial intelligence at the moment.
By what percentage? 99, 90?
Well over 90%.
101?
Not 101. I know the universities like the Dankimadi and a few other startups actually trying to build their own models as opposed to picking an LLM and just picking an LLM that was built from the north and then just trying to either fine-tune or do RAG or other things. I think for me the importance...
So like when you talk about building their own models, like don't you think the cost might be like a bit too much? Because like I was seeing something and GPT-4 was trained at a cost of $50 million. It was so expensive.
I think that was GPT-3. 3 or I think it's 3. That's very expensive.
It's extremely expensive.
It's serving as many, about 100 million people.
So many people.
Not really. Let's say about anywhere between 45 to about 50 million active users monthly. But when you look at that scale, you're not going to do the same, because it's not apples to apples when it comes to artificial. Most other technologies, what you build out there and what you import, the market just accepts. With artificial intelligence, the North is predominantly enterprise driven. So you can build large scale because people can afford. Even the end consumer, the edge, has very reliable internet, and that's very cheap. They have devices capable of connecting to the internet, and they're able to pay for ChatGPT.
But when you talk about scale, can we talk about efficiency? Well, because if I build a simple model without spending so much money on it, and I want it to serve the people in a very, very nice way, is the efficiency more is the efficiency more important than the scale? Because for myself, I think the scale is not that important. But it's simply the efficiency, meaning that when you spend this much money building this particular model, the model can now serve us in a very, very efficient way. Because if you do have a self-driving car from Kenya and from Musk, you want the one that will basically make sure that you simply don't now crash on a track. Because the one from Kenya, because of some minimal cost, they maybe now train it for some now less time. You see,
I think the use case matters. So for me, when I'm saying we don't need something as big as ChatGPT, I'm taking into consideration where Kenya and most of Africa is. If you were to build an LLM as big as ChatGPT in Kenya, it will not be consumed predominantly by Kenyans. It will be consumed externally. If you're building it for Kenya, you when you look at the statistics around Kenya and you say the cost of internet is still too high. Not everyone has a phone with internet. So now you're looking at, all right, and how often would everyone use it? Our markets are predominantly SME. How often would someone within the SME space move from paper and pen, brick and mortar, and immediately leapfrog to AI, skip maybe getting a website, skip all that traditional process of growth to go there? And you also look at people's income. The majority of people who are earning a daily wage, and you're telling them to spend 2,000 shillings on ChatGPT. If you build it in Kenya, you will charge people 30,000 a month. So because of the cost. So what's the alternative? You build smaller models that are specialized to our use case. ChatGPT is a very good enterprise tool. Maybe you need a small localized tool that can run on an edge device, where you decide we'll have it run on people's phones or laptops, and there are models which are small enough to do that. And then you update them as required, because you're not updating this model. It's not a live event that you're watching online. So you don't need the internet connection. If you have something that can run on that edge device, and then when an update is required, it updates.
Okay, so I think one thing that we've seen, because so many of these particular models now, the more compute, the more data, they simply become better. So don't you think that's a factor? Because in Kenya, first of all, energy is a very, very big problem. It's first of all extremely high. The way we still produce it, it's not sustainable in some way. We don't have now efficient solar, efficient nuclear, there's none in particular.
So solar wouldn't be the best for obviously powering AI compute, but you mentioned nuclear. So nuclear, there are plans by the Kenya.
It was by 2035.
I think their work commences 2027, and I think it does finish 2035 or 32. And that plant, one could help put more power on the grid for consumers and industry. And if there's power left, it could be used to power these data centers. But already there's, if you go to the geothermal, where there was
I saw
the deal between Microsoft
and Carrier at some point. Okay, but I think there's some untapped potential. Because there's the things that the government wants to do, and I myself, to be honest, I don't now, I simply now don't attach them so much. because of the now previous past.
Yeah.